an example for a left-tail test for proportion. So in this example, a store manager claims that the proportion of customers who buy bacon from a local farm is less than 0.1782. To verify the claim, the manager observes randomly selected sales records for bacon, and he finds that 12 out of 97 sales records show that the bacon was from a local farm. So we'll have to verify claim using alpha equals 0.15. So just by reading the question, you can understand that the parameter that we're trying to test is the proportion of customers who buy bacon from a local farm. So the claim made about that parameter is P less than 0.1782. Since that isn't an equal to in the statement, in step 1, where we define the test, the given claim will be represented by the alternative. It is because you don't see an equal to that. So if this statement is P less than 0.1782, the counter argument is in the null, which is P greater than or equal to 0.1782. The alternative is pointing to the left, so this is a left-tail test. With the claim in the alternative. Step 2. Since alpha is 0.15, this is a test with 85% confidence. This is a non-traditional value because the standard values of alpha are either 0.05, 0.1 or 0.01. But sometimes you can actually use an alpha of 0.2 or 0.15. But nothing less than 0.2 or 0.15. Step 3. We have to find the test statistic. The test statistic here is a score statistic, which is given by z is equal to p hat minus p naught divided by square root of p naught times 1 minus p naught over n. So in step 3, we find the test statistic, which is the score test statistic, which is given by this formula right over here. P hat is the sample proportion, which is x over n, where x is the number of customers who bought bacon that was from a local farm, divided by the total number of customers. So 12 out of 97 customers purchased bacon that was from a local farm, therefore P hat is 1237. P naught is the claimed value of the proportion, which is 0.1782. N is the sample size, so we just have to plug in all these values in the test statistic formula, which is 0.1237 minus 1.1782 divided by square root 0.1782 times 1 minus 0.1782 over n, which is 97. That would give you an answer of negative 1.4026. Step 3 is now complete. The next step is to identify the distribution of the test statistic. For this test, which is a left-tail test for proportion, the test statistic has a standard normal distribution, which is a normal distribution with mean 0 and standard deviation 1. The next step is to find a conclusion, and you can find a conclusion in one of two ways. So the first approach is the critical value method, where we find a critical value and compare the test statistic to the critical value. So since the test statistic has a normal distribution, I'll go ahead and sketch that out. And since this is a left-tail test, the rejection region is on the left-hand side. The area of the rejection region would equal to the value of alpha that we set in the beginning of the test, which in this problem is 0.15. The critical value here is denoted by z sub alpha, which is the critical value from a standard normal distribution, so that the area below the quantile is 0.15. So z sub 0.15 is equal to inverse norm of the area below. The area below is 0.15, and that should give me the critical value. We could do this using the calculator as follows. Option 3 is inverse norm, 0.15, close paren, press enter, you get negative 1.036. So the critical value is over there, and my test statistic is negative 1.4026, which is right over there. That is from step 2. So this is the test statistic, and that is the critical value. Clearly the test statistic falls in the rejection region over here, therefore we reject the null. If we reject the null from step 1, we know that the definition is null. P is greater than or equal to 0.1782, and the alternative is P less than 0.1782, and the claim was the alternative. Since we reject the null, we sort of crossed it out in a hypothetical way, so that cannot be true. So the claim is true. It is true with some probability. So that is the critical value method. You could also find a conclusion using a p-value method, and if you choose to do a p-value method, with the p-value method we find a p-value. And what is the p-value for this test? The p-value for this test is the area below the test statistic. It is not above, it is not 2 times the area above the absolute value of the test statistic, because this is a left-tail test. For a left-tail test, the p-value is the area below the test statistic. So you have to keep in mind that the p-value is dependent on the type of test, whether it is a left-tail test, a right-tail test, or a two-tail test. So in this problem, the test statistic has a normal distribution, and the test statistic is negative 1.4026, and we like to find the area below negative 1.4026, and that number is the p-value. We find that area using normal CDF, which gives us a probability. It is the area below, so you start at negative infinity, which is the smaller number compared to negative 1.4026, and 0 and 1. You may or may not specify the mean and standard deviation in this case. If you don't specify the mean and standard deviation, the calculator would assume that the mean is 0 and the standard deviation is 1. So let's clear this and let's find the p-value. So press number 2 and start as negative E99, comma, end at negative 1.4026, close paren, press enter, you get 0.0803. Therefore, the p-value is 0.0803. So, is p-value less than or equal to alpha? If we say yes, we reject the null. If we say no, we fail to reject the null. The p-value in this problem is 0.0803, and the alpha that we set in the problem is 0.15. So clearly it is less, so we reject the null. This is the same conclusion that we had previously. The amount of probabilistic evidence that we gathered toward the null is the p-value itself, which is 0.0803, 8.03%. The evidence toward the alternative is 1 minus p-value, which is 1 minus 0.0803, which is 0.9197 or 91.97%. So you can clearly see that you have more evidence toward the alternative than the null, so the alternative is more likely to be true. Although this informal approach could be used in certain situations, using the evidence-based conclusion could get quite confusing. For instance, if the evidence toward null is 49% and evidence toward alternative is 51%, then you're sort of evenly split. So in that case, it's always best to use the alternative or formal interpretation of a p-value, which is p-value is the amount of error in rejecting the null. So if I rejected the null in this problem, which is what I chose to do, the error is 0.0803. And I'm asking a question, is this value less than the level that I set? Is this p-value less than or equal to the amount of error that I set at the beginning? So what I got from the data was 0.0803. What I set is 0.15. In other words, if I happen to reject the null, I am perfectly content with 15% error or less. Clearly, in this problem, I have only 8% error, therefore I am very happy in rejecting the null. Therefore, my conclusion has to be reject null. The entire process can also be accomplished using a calculator. So, if we go back to the question, we'll actually find the things that are needed to plug it in the calculator and get an answer, provided you are using the score statistic. So press start, go over to test, select option number 5. The P naught is 0.1782. X is the number of people who bought bacon that was from a local farm, which is 12. The total number of customers we observed was 97, and the type of test that we are performing is a left tail, so you select the second one. So press enter, then you press calculate, and you find that the test statistic is negative 1.40023. That's exactly what I have. The p-value is 0.0804, very close to what I have, and p-hat is 0.1237. Those are all conclusions that we obtained using the manual approach. If you go back here, you can see that p-hat is 0.1237. It's exactly what I have over there, and the test statistic is negative 1.4026. That's exactly what I have over there. You can differ by a few decimal digits because of rounding, and that's exactly what's happening here. I'm getting, with the manual approach, negative 1.4026, but with a calculator I'm getting negative 1.4023. If you did it right, both approaches will give the exact answer up to 3 decimal places. So the p-value also agrees, our p-value agrees with what the calculator gives. So that is how you perform the test using a calculator. If you want to get out the p-value, just like what I've done over here, you could go over to tests and select number 5. Instead of calculating, if you just said draw it will sketch out the area below the test statistic, which is nothing but the p-value that I drew in red over here. So that is how you perform a left-tail test for proportion using the manual approach and using a TI Science Epic calculator. I hope you learned something from this video. Thank you for watching.